In this tutorial, we're going to build a multi-peer video chat web application using Django, WebSocket, and WebRTC. So let me just show an example of what it will look like. So it's going to ask for our microphone, our webcam and microphone, and then if we enter a username, we can join the room. And let's duplicate the tab. Let's allow it, and if we enter another username and join the room, then it will be connected. Okay, let me mute myself. This way we'll be connected to the other client here, and let's add another client. Let's allow our webcam and microphone. Let's give it the username C. Join room. Let me mute myself. Alright, then there are 3 videos on each side. So that's what we're gonna build. Let's get into the tutorial. Alright, there's also going to be chat functionality, so let me demonstrate that. Username B, join room. Let me mute myself. And so if I say hello, it's going to be sent to the other client. And if I say hi, it's going to be sent to the other client here. So let's get into the tutorial. Before we start, I'm going to assume that you can write programs using Python and JavaScript, and also you can write web applications using Django. I'd highly recommend that you check out WebSocket and how to write WebSocket code using JavaScript, and also you should definitely check out django-channels library, because that's what we're going to be using to build our consumers, which our clients are going to connect to using WebSocket. And also you should check out WebRTC and learn the fundamentals of it, and you should learn how to write basic WebRTC code using JavaScript. Because the reason that these are recommended is because I'm not going to get into the fundamentals regarding these things. All I'm going to be doing is explaining the code that I'm going to write. So I've created a directory for the project and I've named it Django Video Chat. So let me just navigate to that from the command prompt. Now I'm going to create a virtual environment, and if you're using an IDE like PyCharm, you probably won't be needing this step. Okay, now there's our vent folder, which is our virtual environment, so let me just activate it. Again, if you're using IDE, you probably won't be needing these steps. Now before installing any new packages, let me just upgrade pip. Okay, now let's install the latest version of Django, which as of now is I believe Django 3.2. Okay, now let's create a Django project using Django admin. Let's call it my site. Okay, as we can see that we got our project folder in here. Okay, now let's create a new app called chat. So for that we'd have to navigate to my site, and there we'll use the manage.py module. My start app chat. Okay, so as we can see, we got the chat directory here, which is our app. Alright, before we go any further, let us create our static folder, which will be in our main project directory. So okay, it'll be right where manage.py is. Let's create static, and then let's create a JavaScript file. Let's call it main.js. Okay, we probably should put this put the main.js inside a JS folder. So let's just do that. Okay, I guess I should cut it and paste it over here, and we're good to go. We won't be doing anything with the main.js for now, so let's move on to our templates. So our templates will be right underneath the chat app. So let's create a directory, and we're also going to need another directory with the same name as our app, which in this case is chat. So let's create an HTML file in here and call it main.html. Alright, I took the liberty of using an old HTML template because it's going to be the same stuff every time, so let us get into the essential parts. Okay, let's load the static tag. Okay, let me create an h3 tag for our username. So, okay, let's give it an ID, username, and let's put username for now. And let's create a div for our input where we'll input our username. Okay, and let's give it an ID, username input, and let's put a button over there to send our input. So, and let's call it button join. So this is the button which will press in order to join the chat. So let's put a text join room and let's hit save. Okay, let's just change a few things here. Let's call it label username, and let's call our input as simply username, and let us create another div, and let's give it a class and call the class main grid container, and we'll describe the styling later. Alright, let us create a new div and call it, let's call it video container, because it's gonna hold all our videos. And let's create another div within it, and let's put a video tag for our local video. Okay, so that's what we're gonna call it, local video. And let's put some styling, style, float left, and let's provide autoplay and plays in line. Also, we're gonna need two buttons. Let's just copy it. Okay, let's do it later. Okay, these buttons will essentially act as toggle buttons for our audio and video. So let's say audio mute, and the ID is button toggle audio. Let's just copy it and do the same for video. Let's say video off. Alright, now let's design our chat section. So we're gonna need another div. Okay, let's call it chat, and let's put an h3 tag over there. Okay, chat, and let's put another div and call it messages, and let's put an ordered list, call it message list. So what's gonna happen is that whenever we send or receive a message, is going to be appended to the unordered list as a list item. So let's call it message list. Alright, next up we're going to need another div. Let's put another div over there, and inside that, inside that div, we're going to need an input to type our messages and a button to send them. So let's call the input MSG, and let's call the button btn send MSG, and let's put a text send message. Okay. Also, let's put another button for sharing our screen. So let's call it button share screen, and let's put a text, say share screen. Okay, now let's see what our HTML should look like. At first we should have a label, and it should display username, which will change later with the username that we select. Then we'll have an input for username. And here we'll type in our username, and then we'll press this join room button, and our username will be set to the one that we typed. And then we should have a video element and two buttons which say audio mute and video off. Then we'll have a chat box. We'll have an input where we can type our chat messages, and then a button to send our chat message, and then we'll have a button which will display share screen. So let's see what it looks like. Okay, as we can see, let's just ignore this part from now. As we can see, we have this username label, and then this input where we can put any username that we want, and then if we press the join room button, it will set our username, and we can enter the room. One thing to notice is that our video element is missing, or at least we cannot see anything. That's because we haven't yet specified the source. So when we'll get the video stream for the video element from our webcam, and then we'll set the source, the video source, to that stream. And then we have these audio mute and video off buttons. Then we have this chat message input, and the send message button, and also the share screen button. So everything looks good to go. Okay, let's add some minimal styling, and in order to keep this video from becoming unnecessarily long, I will not explain the CSS code, but rather I'll copy a few lines of CSS, and hopefully you can type it on your own by pausing the video. So I'll add a new folder under static, and inside that folder I'll add a new file. Let's call it main.css, and I'll just put this code over here, and you can follow these steps and pause the video and copy these lines of CSS. Alright, let's add this CSS to our main.html, and let's go to our main.html and put a link tag. Okay, link style sheet, and type text / CSS and src. Okay, so from static, the name is css / main.css. Okay, so it's under static, and under CSS, the name of the file is main.css. Alright, one thing here, it's not src, it should be href. Alright, let's take a look at how a peer-to-peer connection is established between two peers. So in order to establish a peer-to-peer connection, both peers need special information about each other called a session description protocol, or SDP. Each peer will need to send their SDP to the other peer, and in order to do that, they're going to use an intermediary server called a signaling server, and both peers will connect to the signaling server using WebSocket, and since the signaling server knows the locations of each peer, it can relay messages between the two peers, and that way the two peers will exchange their SDPs with each other. So once both peers have each other's SDPs, they can establish a peer-to-peer connection, and afterwards they will not require a signaling server because they can communicate with each other using the peer-to-peer connection. And in our case, our signaling server is implemented using django-channels, and let's take a look at an illustration. So here, if we assume that this laptop is our django-channel signaling server, and also assuming that we have two peers, one using a Chrome browser and the other a Firefox browser, we can see that both the peers connect to the Django channel signaling server using WebSocket, as indicated by the blue arrows labeled 1 and 2. And afterwards, they exchange their SDPs, as indicated by the blue arrows labeled 3 and 4. So once they have each other's SDPs, they have established a peer-to-peer connection with each other, and then they can communicate with each other directly without the intermediary Django channel signaling server. And it is indicated by the orange arrow labeled 5 in here. So we can see that it's a two-way arrow indicating that they can send and receive messages to and from each other. Alright guys, I do understand that I've oversimplified things here, and that's on purpose. I don't want to make this video unnecessarily long, and I do recommend that you check out more detailed videos or read detailed blogs about the core concepts of WebRTC before continuing. Okay, now let us install and set up Django channels, and for that we'll need to go to the official documentation of Django channels. So let's type Django channels. Here is the official documentation, and let's go to installation. Okay, so we'll have to copy this and execute this command, Python Django channels. Okay, now we have to specify channels and under our installed apps. So let's go to settings.py, and under our, okay, let's just make it bigger. Okay, and under installed apps, let's just put channels. Next, we'll have to put these lines of code in a file called ascii.py, and if you're using Django 3.2 like me, then you'll have this file by default. But if you're using an older version of Django like 2.2, then you'll need to create this ascii.py under your main project app, which in our case is my site, and then my site again. And under this my site, you're gonna have to create this ascii.py, and then you're gonna have to put these lines of code there instead of these. So let's just copy these. Let's go to ascii.py. Let's just remove all of these, and let's paste the ones that we copied. So for now, we've specified HTTP only, and then we'll move on to WebSocket. Next, we're gonna have to go to settings.py and then specify that our project has to use this router variable, which we named application here. So let's go to settings.py, and at the bottom let's write ASCII application, we'd have to specify the route to that variable. So in our case, it will be mysite.ascii.application. Alright, one small thing that we should do before we continue is specify our app, which we name chat, and also let's just import our main.js. So we'll get to that later. Let's import main.js in here. So let's put a script tag, type text/javascript, and source will be, again, it's under static, so let's say static main dot, alright, js/main.js. Next, we'll define our view function. We'll only need one, and so under views and views.py, let's define main view, then request, and okay, let's put an empty context because we won't have anything. Just return render, and let's pass in request, and the name of the template is chat/main.html. Then let's pass in context equals context, and then let's specify our URLs. But before that, we'll need to create a urls.py file. So let's put a new file, urls.py, and from django.urls import path, and from .views import main view, and URL patterns equals, okay, let's put path, so empty string, and then let's put main view. Let's give it a name. Let's simply call it main view. And in our main app URLs, let's just copy this and put an empty string. So we want to go there using only our host name. And okay, we'd have to import something. Import include. Then let's use include. So include chat.urls. So then it will be routed to our chat URLs. Okay, there's one thing we should fix. I think it should be URL patterns without the underscore, and let's write something in our main.js to check if it's working. Let's put console log and in main.js, and let's run our server and see if our view is working. Okay, then so we can notice something here. Instead of the usual, it now says starting ASCII/django-channels, is because we've specified some things in our settings.py, and now django-channels has taken over the development server. So let's just see if our views are working. Alright, so we got our HTML page here, so let's see if our JavaScript is working. Okay, there doesn't seem to be any console log output, so I think it probably has to do with the fact that we didn't specify our static URL in settings.py. So there's our static URL, so I think we need to specify static root. Right, we're going to need something called static files dirs. Static files dirs equals will be list os dot
path.join, and then we'll specify our base dir here. Alright, base dir, then static. So it'll take our base directory, which is my site, then it'll go to static to retrieve our static files. So let's see if it works now. Okay, I think we stopped our development server. Okay, yeah, so we didn't import OS. So let's just import OS here. Import OS and run our development server again. Now it should work. Okay, there it is. So we got our HTML page. There's the video element, which doesn't have any source. We'll get it from our webcam. So we have everything we need here. We also have this JavaScript console log output in main.js. Alright, next let's define our consumers. So under chat, let's create a new file called consumers.py. So these are essentially like views.py, except that our clients are gonna connect to our server using WebSocket, and they'll connect to these consumers. Now we need to make some imports from channels.generic.websocket import async WebSocket consumer. So we'll need to create a class. Let's call it chat consumer, and it will extend this async WebSocket consumer class, and we'll have to define a few asynchronous functions. So let's define them. Async def connect, which will be triggered whenever a client connects to a consumer, and then we'll have to define async def disconnect and self again. Then we'll have to define async def receive. So disconnect will be triggered whenever a client disconnects, and receive will be triggered whenever a message is received from a client. Alright, now let's define this connect function, and the way we implement a chat room in using Django channels is by leveraging a feature called groups. So groups are essentially like rooms, and what they do is they keep channel names. So each peer that connects to our Django channel server will have a unique channel name, and groups essentially keep a collection of these channel names. So whenever a peer sends a message, that message can be sent through all the channels that are in the group, and then in that way that message will be broadcasted to all the peers. Alright, before continuing, I'd highly recommend that you complete the tutorial and the official documentation of Django channels before continuing, as that will help you grasp the concepts really well. Alright, let's assume that whenever a peer connects to our server, they will be connected to the same room as all our other peers. Let's assume that we have only one room for now. So let's create an attribute variable. Alright, okay, self dot. Let's call the attribute variable room group name. So this will be the name of our group. So each group will have a unique name. That's how we distinguish between groups. So let's call it test room. Let's call it test room, and okay. Then we'll need to connect. So whenever a user connects to this consumer using WebSocket, we'll have to add them to this group. And for that, we'll need this function. right? It's an asynchronous function, so we'll need to use a await self dot channel layer dot group add. So we'll need to use this group add function, and we'll have to pass two arguments, one being the group name, which we have here, self.room group name, the one we defined here. And again, we're assuming that we have only one room for now. Later we may add more rooms, so all we need to do is change the name of the room, so we can do that later. And we'll need to provide the channel name of the peer that is trying to connect. Self.channel name. All right, and then we'll simply accept the connection. So, all right, this will be await self.accept, and let's define our disconnect function. Whenever a user disconnects, we'll simply discard their channel name from the group. So await self.channel layer dot group discard. So let's discard it from the room or the group. So the arguments will be the same. Will be self.room group name and self.channel name. And in the end, let's just print disconnected. Alright, disconnect is likely to take another argument. Let's call it close code. Alright, the reason we're defining these functions is because these functions are in the class async WebSocket consumer, and since we're extending this class, we're going to need to define these functions for our use case. And okay, let's define receive. It's going to take another parameter, another argument. So let's name the parameter text data, and we're going to need to make another import. So let's import JSON. How we write this receive function is going to depend on our specific use case, and we're going to write most of the code for sending our SDP to other peers and notifying every peer whenever a new peer joins the room. So okay, I've changed it to dict data instead of text data because from our JavaScript, we're gonna send a dictionary or object in JavaScript in JSON format, and this parameter is going to hold that dictionary. So when we receive that dictionary, what we have to do is we have to deserialize it because it's going to be in JSON format. So let's call it receive dict. Receive dict equals JSON.loads that will deserialize our dictionary. Dict data, so it will now be considered a Python dictionary. And let's say we have a message in that dictionary, so let's call it message. Receive dict. Let's say we have a message attribute in that dictionary. Alright, now this part essentially means that our consumer has received a dictionary from a peer, and it has extracted the message from that dictionary. So it's gonna work because we're gonna send a dictionary which has this message attribute, and then we're gonna have to send this message to all the other peers. So we're gonna need to use a function. So let's call it await self.channel layer, the same thing, dot group send. All right, now this function is gonna send it to all the channels, broadcasted through all the channels connected to this group, and we're gonna need the group name. Let's go self.room group name, and then we're gonna have to send a dictionary. This is where things get a little bit tricky, because in this dictionary there has to be a compulsory key called type, and the value will be a string corresponding to the name of the function that the consumer will use while actually sending the message to each peer. So let's define let's name the function first. So let's call our function send message. It can be whatever we want, and let's pass in self. It's gonna take an argument. Let's call the parameter event, and since we named the function send underscore message, we have to write send dot message as the name in type. So that's just the way it is. As for the following key value pairs, we can send whatever we want. So let's say we want to send a key value pair. Let's say we want to send this message here. So let's call the key message, and let's pass in this message variable, and we can access this in here. So in order to get the message, let's put message equals event. So is the dictionary, and this event dictionary will contain this message key value. So let's pass in the key and we'll get the message. Then we can send this message to the other peer. All we have to do is await self.send. It's going to take an argument in the parameter text data. Text data equals. So before sending, we'd have to serialize it to JSON. So from Python dictionary is going to become a JavaScript object. So okay, it's a function JSON.load_s, then it's a dictionary, and let's say message. Let's send a key value pair, the key being message and the value being this message variable. Alright, I made a mistake here. It's going to be dump s, because when we're using load_s, we're converting from JSON to Python, as in the case here, and since we're now converting from Python to JSON, we're going to use dump s. And also, let's just change it back to text data, because since we're receiving the data in JSON format, it is essentially text data. And then we convert it to a dictionary. Alright, let me go through what's going on here. This group send function broadcasts our message to all the channels in the group, and it does so by using the send_message function that we defined in here. And each time it sends a message through a channel, it invokes this send_message function, and then it invokes the send function within it to send our message. And the message is in the form of a dictionary that is serialized, and the dictionary contains the key called message and a value which contains our message variable. Alright, so far we've been using this self.channelLayer thing in here, but we've actually not specified a channel layer, so let's go to our settings.py and do just that. So I'm going to go back to the official documentation of Django channels, so let's go to channel layers, and let's find in-memory channel layer and copy it whole, and let's just put it right there. Alright, a couple of things here. This in-memory channel layer is not suitable for production, and I'm only using it for the purpose of this tutorial, as I understand that not a lot of people can configure something like Redis. But if you're trying to build a real-time application for production, then you should probably configure something like Redis. And after you do that, all you have to do is go to the official documentation, copy and paste, copy this thing from here and paste it over here in place of the in-memory channel layer. All you have to do is specify the host in here and the port right here. So I'm just gonna erase that for now. The reason I'm using this in-memory channel layer is because to use something like Redis is beyond the scope of this tutorial and what I'm trying to accomplish, and also because I understand that most people would find it really difficult to configure Redis on some platforms like Windows, like me. And if you're using Windows, you can use Docker to configure Redis. And if you're using Linux, then I think configuring Redis is something very easy to do. And the same goes for Mac OS, I believe.
Alright, now moving on, we have to specify our routing. Essentially, routing is analogous to urls.py, just like consumers.py is analogous to views.py. So under our chat app, let's create a new file called routing.py, and let's make a few imports from django.urls, import repat, and from .import consumers. Now, just like URL patterns for views, for WebSocket, we're going to define WebSocket URL patterns, and let's just define that. It's going to be in a list, and let's use our repat as a function, and using just our host name will be routed to our consumer, which is the one that we defined and named chat consumer, and we're going to use the function called as ASCII. And with that, we're done with the minimal implementation of Django channels. Now let us write some JavaScript. What we'll do is we're gonna get this label and this text field and this button, and we're gonna write something in this text field, and we're gonna implement an on-click listener on the button so that whenever we press the button, our username gets set and it gets displayed in here. So let's do that. In our main.js, let's get the label first. So var, let's name it label username, and document.query selector, we're gonna select it using its ID. So ID username, so I believe it was simply username. Okay, it was label username, and the input will be username. Okay, now let's just copy it, put it over here. Let's do the same for the input username, and it's only username. Let's do the same thing for the button. So let's call it btn join, and the ID is btn-join. Alright, let's put username input. Now let's add an on-click listener to the button, but before that I'm gonna declare another variable called username, which will hold the actual username that we type in. So let's now define the on-click listener. So button join dot add event listener, click, and the function will be defined like this. So essentially, at first we'll get the input value. So let's put username equals username input dot value, which will give us the value that we typed in, and we'll then check if the value is empty. If username equals empty string, then we'll simply return, because if the username is empty, we can't join the room. If the username is not empty, then we'll simply clear the input, and we'll set the value to empty, and then we're gonna disable the input so that we cannot change our username or try to rejoin the room in any way. Username input dot disabled equals true, and username input dot style dot visibility equals hidden. So we're going to do that in order to avoid clashes after we've joined the room.
Otherwise, somebody might try to join the room after they have initially joined it. So let's do the same for the button. Button join. And afterwards, okay, let's just take it over here. So what we have to do now is set the label to our username. Label username dot inner HTML equals username. Well, I did notice that there was a small autocorrection, so it should be style, and then here as well. Alright, let us console log our username as well. So username, so it'll be easier to debug. Alright, now let's see if it works. Okay, let's put a username, let's say hello. Alright, so there it is, username hello, and there's our username. Now let's start building our connection, and I highly recommend that you check out the Django-channels video on coding entrepreneurs, because that's where I learned these concepts. Okay, now we're going to need a variable called loc, and let's assign it the value window.location. Window.location will return an object which contains information about our current location, and let's declare another variable called WSStart, and this will specify that we're using WebSocket, and let's put the condition that if our current protocol, log.protocol, if our current protocol is HTTPS instead of HTTP, then our WSStart will be WSS, or WebSocket Secure, and we're going to need another variable called endpoint, which will contain the URL that we will use in our WebSocket to connect to our consumer, and the endpoint will be the entire the concatenation of all the strings WSStart and loc.host and loc.pathname. So if I console log it, we can see what it looks like. Console.log and endpoint. Okay, now let's save and see what it looks like. Okay, let's put a username. Alright, so there's our endpoint, WS, then this path. Now let's create a WebSocket object, but before that, let's declare a global variable called WebSocket, and let's instantiate this variable in here. WebSocket equals new WebSocket, and let's provide our endpoint. That way it will be connected to our consumer. Essentially what will happen is when we connect using this endpoint, it'll be routed to our chat consumer that we created, and a new instance of the chat consumer will be created for each connection. Alright, now we're gonna have to define a few event listeners, so let's just do that. WebSocket.add event listener. We're gonna have to do it a bunch of times, so let me just copy this. Okay, let me copy this. So we're gonna define the onOpen listener, the onMessage listener, the onClose listener, and the onError listener. Alright, now for connection for onOpen, let's just simply console log connection opened, and let's just copy this thing here. Okay, it's going to be the same for on close and all that other thing. So connection closed. And for on error as well, it's going to be error occurred. And for on message, let's define a new function. Okay, let's just write WebSocket on message, and we'll define that function right now.
Alright, now let's define this WebSocket on message function, which will be triggered every time our WebSocket receives a message from our consumer. So let's write function WebSocket on message. It's going to have one parameter event, and okay, what we have to do now is we have to receive the data that we sent from our consumer. So if we remember, our consumer is going to send a JSON string after serializing a Python dictionary. So what we have to do is we have to deserialize that JSON string, and in the process receive a JavaScript object. So let's call it parse data. Okay, so in order to deserialize it, we have to call json.parse is equivalent to json.load as in Python. So we're gonna parse the JSON string, which we'll get from event.data, and okay, we're gonna extract the message from it. So as we know that the dictionary we're sending has a message key, so we're gonna use that. Message equals parse data message. Now we're going to receive the message, and for now let's just console log it and see how it goes. So message equals message. Okay, now we've defined all our functions. We defined WebSocket on message, on open, on close, and on error. So let's check our development server. Let's refresh. Let's put in a username, hello. Okay, as we can see, there was an error and the connection is closed, which means that it triggered our on close and on error functions. So let's see what that's about. In our console, we can see that it says no application configured for scope type WebSocket. So okay, I forgot to do that. What we need to do is we have to go to ASCII and specify our WebSocket routing. In our ascii.py, we already have HTTP. So now we need to add the routing for WebSocket. But at first we need to make a few imports. So import URL router, and from channels.auth import auth middleware stack, and import chat.routing, the routing that we specified for our chat app, and let's call auth middleware stack, and then URL router chat.routing.websocket URL patterns. So we've just specified the routing that we defined in here in routing.py. It should be URL patterns. Alright, now let's check our development server. Let's refresh. Let's add a username. Alright, so as we can see, our connection has opened and there is no error. It's not closing down. Alright, now let's test our WebSocket on message function by sending a message to our consumer. What will happen is that after we send a message to our consumer, the consumer will send that message to all other channels or clients in this group. Based on our use case, our consumer expects to receive a JSON string, which it will receive as the argument to text data. It will then deserialize text data and receive a Python dictionary. And then it will extract our message using the message key in the dictionary. So from our JavaScript, we have to construct a JavaScript object and give it an item with the message key, and then serialize it before sending it. For testing, we're going to send a message as soon as our connection has been opened. So in our WebSocket on message, let's define our JSON string, JSON str. We have to call JSON.stringify, which is equivalent to JSON.dumps in Python. It will receive a JavaScript object and serialize it. We have to provide a key called message, and let's provide a value. This is a message. Then we need to send this JSON string, WebSocket.send JSON str. This will send the JSON string. Therefore, all our peers should receive and output the same message. Let's try it out. Let's refresh and let's put another username and try to connect to our WebSocket. And there it is. Connection opened and message. This is a message, which means that our onMessage function is working. Alright, now let's get our local audio and video from our microphone and webcam respectively. Let's define a variable, call it local stream. It will contain a media stream object. Let's just initialize it with something for now. And later, local stream will be assigned a media stream object, which will contain our local audio and video. And this will later be used as the source for our video element over here. And let's define our constraints. Constraints. Here we'll initialize a dictionary which will specify whether we'll use audio or video, and we can also set other constraints as well. For now, we'll only specify that we're going to be using both audio and video. Now let's access our webcam. We need another variable. Let's call it user media, and then navigator.mediadevices.getUserMedia, and then we need to pass in the constraints. The code is asynchronous, so we need to make sure that it fully executes before moving on to the next part. Once getUserMedia has finished executing, it's going to return a media stream object. Let's call it stream, and let's define a function to execute afterwards. Okay, we're going to need our local video, const local video. Let's get it from our HTML document.querySelector. Its ID was local-video, and that should give us their local video. Now we're gonna assign this stream variable to our local stream equals stream. Now let's assign this local stream as the source to our video element. So local video.src object equals local stream, and let's mute ourselves because we don't want to hear ourselves talking in a video call. Local video.muted equals true. And in case we encounter an error while trying to access media devices, let's catch that error. Alright, error. And let us console log the cause for the error. Let's say error accessing media devices, and let's console log the error. Now let's go to our development server and check if we can get our webcam. Alright, so there it is. It's asking for permission as we're trying to access our webcam. So let's allow it. And there it is. There's my video over there. And okay, let's refresh and don't allow. Okay, there it is. There's our error because it couldn't access our webcam because we didn't allow it, and now it console logs the error. Alright, we got our signaling server in place, and we can also connect to our signaling server using WebSocket from the client side, and we can access our local video through our webcam using getUserMedia. Now we can move on to building our peer-to-peer connections using WebRTC. So let me go through the scheme that we're going to follow. What's going to happen is that whenever a peer joins the room, it's going to send a message to all the other peers, which will indicate that there is a new peer. And all the other peers that are currently in the room will get notified of this new peer through this message. Then each existing peer will initiate a peer-to-peer connection with this new peer by sending it an offer SDP through a message, and the new peer will receive each offer SDP. The new peer responds to each offer SDP by sending each one of them an answer SDP, and all the other peers receive their respective answer SDPs. And in this way, the new peer is connected to all the other peers, forming a peer-to-peer mesh. And of course, I've oversimplified things here in order to keep this video short. And let's look at what our architecture will look like. So this is what a peer-to-peer mesh architecture looks like. As we can see that all the clients are connected to every other client. Also, one thing I'd like to point out is that while P2P mesh architectures are okay for learning the basics of WebRTC, it will cause end users to experience considerable latency as the number of peers grow, and as such cannot scale. In such cases, other architectures such as MCU or SFU should be used instead, and I'd highly recommend that you check out those architectures and try to implement them on your own. So far, we've been sending a dictionary for testing, so let's just copy that and put it over here so we can see. Alright, now here we serialized only one dictionary, and the dictionary had only one key and one value. But for actual signaling, we're going to need a few more key value pairs. So one key will be peer, which will always have the value of our username, and one key will be action, which will denote the type of action that we're trying to perform here. Whenever a peer receives a message, it's going to use the action key on the received JavaScript object, and based on the value, it's going to know what kind of action it has to do. For example, whenever a new peer joins the room, it's going to set action to new peer and send the message to all other peers, and all other peers will use the action key on the received object, and when they see new peer, they're going to immediately understand that it is a new peer and that they have to send an offer to this peer. And likewise, when they're sending an offer, they're going to send the action to new offer, and when the new peer receives a message with action set to new offer, then they're gonna send a response and set the action to new answer. Of course, there are a lot of different ways to do this thing, but this is what I'm doing right now. And for message, the value will be another dictionary, and it will have its own key value pairs, which will depend on the kind of action that we're going to perform. All right, now we're going to be sending the message in the same format, and for that, it's best that we define a function for this. All right, let's call it send signal. And since our username will always be the same, we don't need to pass it. So let's just have two parameters, action and message. So all we're going to do is we're going to invoke this function and provide arguments for action, which is a string, and message, which is a dictionary. Also, one thing I'd like to point out is that I'm using the terms JavaScript object and dictionary interchangeably because I'm more used to saying dictionary, and I don't think it really matters because they do the same thing essentially. So I hope people don't get confused. All right, let's just cut that and paste it here, and let's provide our arguments that we will pass. All right, action being action and message being message. All right, now, so we create a JavaScript object, we stringify it or serialize it, and then use WebSocket.send to send it to our signaling server. Now we need to go back to our WebSocket on open function and send a signal once our connection has been opened. So we have to call send signal, and once a WebSocket connection is opened, we will signal that there is a new peer. So action will be new peer, and message will be an empty dictionary. All right, now that we've signaled that there is a new peer, let's handle it from our consumer. So everything else will remain the same, and we know that received dict message will now be a dictionary. And now what we have to do is we have to add another key to it. So receive dict message, which is a dictionary, let's add another key. Let's call it receiver channel name. The thing is that whenever a new peer connects to a consumer, it's going to have a unique channel name, and that's what we have to send to all other peers so that they know where to send a response. So receiver channel name and self.channel name, and this will return the channel name associated with this client. Now let's make a few changes to our send message function. Let's rename it. Let's call it send SDP, and here as well send.sdp, and instead of message, let's send our receive dict. Let's call it receive dict, then receive dict, and in our function we have to extract it by using the receive dict key, and what we're sending now is the serialized form of receive dict. Okay, let's just write receive dict, and let's make the correction over here. Now let's get back to our main.js file, and in our WebSocket on message function, we have to get the username of the other peer. Let's call it peer username. It will hold the username of the other peer. So parse data peer. Let's copy it, and let's get the action in the same way. Var action equals parse data action. One other thing to notice is that whenever a consumer invokes this group send function, it sends the message across all channels that are currently in the group, including the channel that the message originally came from. In that case, we end up receiving our own messages, and so we have to ignore that. Right? I know it should be handled on the back end, but for the purposes of learning, I'm going to leave it at that and simply handle it in our JavaScript. So if username equals peer username, we simply return, and all messages that came from ourselves will be ignored. Now let's handle for the case for when a new peer joins the room. At first, we're going to need the channel name. Let's call it receiver channel name. It will hold the channel name of the peer that we're going to send the message to. So parse data message receiver channel name, and we know that whenever a new peer joins the room, the action will be set to new peer. So if action equals new peer, we handle for the case when a new peer joins the room. Now when a new peer joins the room, we're gonna call another function which we'll define later. Let's call that function create offerer, and we have to pass two arguments, peer username and receiver channel name. So what this function will do is it's going to create an offer SDP and send it to the channel associated with receiver channel name. Now let's return after that and define the create offerer function. Let's put function create offerer. It's going to take peer username and receiver channel name. Now we need to create an RTC peer connection object. Okay, let's call it peer because new RTC peer connection. Let's put null in there. All right, for the purposes of learning, this web app will only be able to connect two devices that are inside the same network, such as the Wi-Fi network in our homes, and it will not work when the two devices are on different networks, and that's the reason we put null in there. And if we want to connect two devices that are in different networks, then we need to set up turn servers and stun servers, which are beyond the scope of this tutorial. And in that case, it won't be null, it will be something different. It will be a dictionary that specifies the turn and stun server credentials. Next, we need to call another function. Let's call it add local tracks, and we will define this function later. We need to pass one argument, which is the RTC peer connection object, and what it will do is it will take our local audio and video tracks and add it to this peer connection so that our local audio and video can be streamed to the other peer. Let's define this function now. Function add local tracks. It'll take one argument, so we'll specify one parameter. Now we access this local stream variable that we declared here, and we add all its tracks to peer. So local stream dot get tracks dot for each. Now we have to define this function. Alright, I made a mistake here. Get tracks is a function, and for every track that we get, we have to take that track and add it to peer. So peer.addTrack. We have to pass two arguments, which are track, the current track, and local stream. And let's just return. Let's get back to our createOffer function and create a data channel for sending data. So peer.createDataChannel. Let's pass in the string channel, and let's define an onOpen event listener. Add event listener open. It will be triggered when our data channel is opened. So let's define this function. Let's say whenever our data channel has been opened, we'll console log connection open, just as we did for our WebSocket on open. Now let's add an onMessage event listener to this data channel. One thing I'd like to point out is that we're not using WebSockets for chat messaging, we're only using WebSockets for signaling. And for chat messaging, we're going to use the data channel that we created over here. So let's add the onMessage event to it. dc.addEventListener onMessage and dc onMessage. And we're going to define this function right now. Function dc onMessage. It's going to take an argument. Let's call the parameter event. Whenever we receive a message through this data channel, it's going to trigger the onMessage event and execute this function. Alright, we need to get our unordered list. Now, if we go back to our main.html, we can see that we have an unordered list with the ID message. So what we're going to do is whenever we receive a message, we're going to append the message to this unordered list as a list item. So let's get this unordered list first. Let's call it message list. Message list equals document.querySelector and ID message hyphen list. That should give us the message list. And when the onMessage event is triggered and it executes this dc onMessage function, it's going to pass to it a dictionary which we will receive as the argument to the parameter event. So we can then extract the message from that. Let's call it message, var message equals event.data. This will give us the message. Now let's create a list item. So var li equals document.createElement, and we're going to create a list item. This will return a newly created list item, and then we're going to append a child to it. So li.appendChild and document.create text node. So we're going to create a text node with our message, and we're going to append it as the child to the list item. Then we're going to append the list item as a child to message list. So message list dot append child li. Next, we'll create a new video element for the remote peer. So var remote video equals create video. We'll define this function later. We'll pass the username of the remote peer, and then we'll call another function set on track. We'll define this function later as well, and we'll pass the RTC peer connection and the username of the remote peer. What it'll do is it will add the on track listener to the peer connection over here. So we'll define it right now. Right now, let's define create video first. Create video, peer username, it's a function. Now if we go back to our main.html, we can see that we have a div with the ID video container, and it has our local video element as a child. The idea is that whenever we connect to a new peer, we're going to create a video element for that peer and append it to this div. So any new peer that we connect to will have its video element appear underneath our local video element, and the last peer that we connect to will have its video element underneath every other video element that are currently in the page. Now let's create the video element. But at first we need to extract this video container div. So let's call it video container equals document.query selector. ID is video hyphen container, and let's create our video element. Let's call it remote video. Var remote video equals document.create element. Video is going to create and return a video element, and now we need to set its ID. Remote video.id equals, its ID will be the username of the remote peer plus hyphen video. So if the username of the remote peer is Tawheed, it's going to be Tawheed hyphen video. So we need to add some other things. Remote video dot autoplay equals true, and let's copy this. Remote video dot plays inline equals true. Now, as we can see here, local video is itself within another div. So let's create another div. Let's call it video wrapper. Video wrapper equals document.create element div, and let's append it as a child to video container. Video container.append child video wrapper, and let's append a child to video wrapper dot append child. This child will be remote video, and then let's just return remote video. Now we need to define the set on track function. We're gonna have to pass our RTC peer connection and our remote video element. Then we need to create a media stream object for our remote media stream. Let's call it remote stream. Remote stream equals new media stream, and let's add it as the src object to remote video. Remote video dot src object equals remote stream, and then we're gonna have to add an event listener to peer dot add event listener track. So is the on track listener, and it's going to be triggered every time we receive a remote track, which could be audio or video. Now we need to define an asynchronous function that will be executed every time this RTC peer connection object receives a media track. So let's write async. Is going to have a parameter called event, and let's define the function. What we're going to do is whenever we receive a track, we're going to add it to remote stream. So remote stream dot add track event dot track, and again we need to pass remote stream. So what's going to happen now is that after we create our remote video element, we're going to call set on track, and it will set the on track listener, which will add the remote media tracks to this media stream, and that media stream will be the src object for the remote video, and that way we can see the video of the remote peer and also hear their audio. Now we need a way to keep track of the peer connections and the associated data channels. So what we're going to do is we're going to keep a JavaScript object which will map each username to the associated data channel and peer connection. So let's define an empty JavaScript object at the top of the JS file. Let's call it map peers. It's going to be empty at first, and now alright, turns out I've made a small mistake here. It should be remote video and not peer username. Now let's add our peer connection to map peers. So map peers peer username equals, so it's going to store a list where the first element will be the RTC peer connection and the second element will be the data channel. Now when a peer leaves the room or cannot connect for some reason, we need to remove their video and close the associated peer connection if it is not closed already. For that, we're going to need another event listener. So let's add the on ice connection state change event listener. Let's define the function that will be triggered. Now we're going to need the ice connection state attribute, where ice connection state equals peer dot ice connection state, and if ice connection state is failed or ice connection state is disconnected or ice connection state is closed, we're gonna delete its entry on the object. So map peer username, we're gonna delete it, and if it is not closed, if ice connection state is not closed, then we're gonna close it. We're gonna call peer.close, and then we're gonna call another function called remove video, and we're gonna pass remote video. And we're gonna define remove video right now. Remove video. It's gonna take one parameter. Well, let's just call it video, and let's get the enclosing div. Let's call it video wrapper. Video wrapper equals video.parent node, and let's remove this video wrapper, and we'll remove the video. Video wrapper dot parent node dot remove child. Let's pass video wrapper, and then the video wrapper will be removed, and therefore the video will be removed as well. Now let's get back to the create offer function, and whenever an RTC peer connection creates an offer or an answer, it starts gathering something called ICE candidates, and we want to make sure that only after it has finished gathering all the ICE candidates will we send the offer or answer SDP to the remote peer. And for that, we need another event listener called the onIceCandidate event listener. So add event listener, IceCandidate, and let's define a function. It's going to have one parameter, event, which will be a JavaScript object. Whenever there is a new IceCandidate, we can get it using the candidate attribute of the event object, and once that happens, we can simply console log it. Alright, let's say new ICE candidate, and let's print it json.stringify peer.local description. Whenever there is a new ICE candidate, the local description of the RTC peer connection will change, and then we'll simply return. When ICE candidate gathering has been completed, the candidate attribute of the event object will be null, in which case we will simply call send signal and send the SDP to the remote peer. So we have to set action to new offer, and then we have to send a dictionary. The dictionary will have a key called SDP, and the value will be peer.local description, and it will have receiver channel name. We need to send the receiver channel name because we don't want to send the offer SDP to all the peers, but only the peer that sent the new peer signal. So every time the RTC peer connection receives an ICE candidate, it will console log the local description, and whenever it has finished gathering ICE candidates, it will signal the offer SDP to the new peer. Then let's call peer.createOffer. It will start the ICE candidate gathering process, and then once we've created the offer, let's set it as our local description, peer.setLocalDescription O, and once the local description has been set, let's just console log it. Console log local description set successfully. Now to summarize what we've done so far, if action equals new peer, Then we call create offerer, and it creates an offer and sends it to the new peer, and it sets the action to new offer. Now let's go to consumers and handle what will happen if the action is new offer or new answer. But at first, we have to retrieve the action string. Now we're going to do the same thing if action is new offer or new answer. So let's write if action equals new offer, or if action equals new answer. Now let's take a moment to understand what's going on here. Whenever a peer sends an offer, it arrives at the consumer first, in which case we have to change the receiver channel name to that of the offerer so that the answer knows where to send back the answer. But first, we need to extract the channel name that is currently in receive dict. Let's call it receiver channel name, and receive dict message receiver channel name, and let's assign another value to it. Let's copy this. All right, let's assign self dot channel name, which is the channel name of the current client, which is sending the message. Now let's copy this part, paste it here. Let's adjust it, and instead of group send, we're gonna use send, because we're only gonna send it to one channel. So let's pass in the channel name here instead of room group name. The receiver channel name is gonna send it to this channel only, and the dictionary is the same. Now let's handle the case when action equals new offer in our WebSocket on message. So if action equals new offer, at first we need to extract the offer. For offer equals parse data message and then SDP, because we use the key SDP in order to store our offer. And then we need to call another function which we'll define in a while, and we have to pass in our offer, then peer username, and then the receiver channel name. So let's define this function now. Right underneath create offerer, function create answerer, offer, peer username, and receiver channel name. A lot of the code in here is going to be very similar to that in create offerer. So let's just copy all of this. Let's copy all of this and put it over here. Then of course we need to make a few changes. Let's remove the part with the data channel, because the answer will not create its own data channel, but when it's connected to the offerer, it's going to trigger the data channel event. So we're going to have to use the on data channel event listener. So let's add that. Peer.add event listener data channel. So it's going to have one parameter. Let's call it E. In this function, we can get the data channel from the E object. So let's add the data channel as an attribute to the RTC peer connection object. Let's call it peer.dc equals e.channel. This will give us the data channel that was created by the offerer. Now let's copy and add the event listeners to it. Let's copy these. Let's add these over here. So it should be peer.dc and here as well. Now let's store the peer connection and the data channel in the map peers object. We have to put it over here within the on data channel event listener. So map peers, peer username, peer, and peer.dc. Now the on-ice connection state change event listener will remain the same. Now in the on-ice candidate event, let's set action to new answer. Alright, so we're good to go here. And let's remove this part because we need to change a few things. Now before creating answer, we need to set the remote description. So peer.set remote description. Let's pass our offer, which is the remote description, and then let's define another function. So after we've set the remote description, let's console log it. Console log remote description set successfully for person S. Let's pass peer username here. So remote description set successfully for username. And then let's create our answer asynchronously. Peer.create answer. This will create the answer asynchronously. And then once we receive the answer, let's handle that case. So once we receive the answer, let's console log it again. Console.log answer created, and let's set it to our local description. Peer.set local description, which will be a, this parameter right here. Also, it should be return peer.create answer. Now we've already handled the case for action equals new answer in our consumer, so let's move on to our WebSocket on message and handle it over there. So in our WebSocket on message, if action equals new answer, let's retrieve the answer first, where answer equals parse data message, and this too we will get from the SDP key. Next we have to set this answer SDP as the remote description to the offerer. So let's get the offerer first. Var peer equals map peers peer username. This will give us the RTC peer connection associated with this username, and then peer.set remote description answer, and then return. Now map peer's username, it should be 0 because we've stored the RTC peer connection and the data channel as a list, where the first item is the RTC peer connection and the second one is the data channel. So let's try it out now. Alright, before we try it out, we need to add functionality to our audio and video mute and unmute buttons, because otherwise when we're connecting multiple peers, we might experience considerable echo because we're on the same machine right now. So let's add the audio mute functionality first. At first, we need to get our toggle audio and video buttons. So, right, let's just copy this. Let's say const btn toggle audio, and the ID is btn toggle audio. Okay, I believe that's the right ID. Alright, guess that is. And let's copy this, and in place of audio, let's say video. Now let's get our audio and video tracks separately. So var audio tracks equals stream.get audio tracks, and let's copy this. Let's do the same for video tracks. Stream.get video tracks. And we have to ensure that audio and video tracks are enabled by default. So audio tracks 0 dot enabled equals true. By default, it should be true, in which case audio will be enabled, and the same goes for video. Now let's add the onClick event listener to button toggle audio. Button toggle audio dot add event listener, click, and let's define the function. What we're going to do now is invert the value of audio track 0.enabled. So if it is true, then we should change it to false, and if it's false, then we should change it to true. So let's copy this audio track 0.enabled. Let's copy this equals not audio track 0.enabled. So we're simply going to invert it, and if audio tracks 0.enabled, if the value is true, then we have to change the text in the button. So .inner HTML equals audio mute. If it is true, we have to set the text to audio mute, and otherwise, let's return it. Otherwise, we have to set the text to audio unmute. And it's going to be the same for the video toggle button. So let's just copy this. Let's put it over here. Button toggle video and video tracks 0.enabled. I think it should be video off, and in here it should be video on. Now let's head to our web page and check if everything's working correctly. Let's refresh and allow, and let's duplicate this tab. Let's give it the username A and this one B. Alright, so there are two videos. Let me just mute ourselves. Alright, that's better. So there are two videos on each side, so let's add a third peer. Let's call it C. Alright, so there are, let's mute this one as well. There are three videos on each side, and if I turn off the video on one side, then it's closed on all the other sides as well. If I turn it back on, then it's visible on all sides again. Now let's add the chat functionality, and afterwards I'll show how to test it out on different devices. Now let's get the send message button. Its ID was btn send message. Let's get that. So var btn send msg equals document dot query selector. The ID is btn hyphen send hyphen message, and let's add an onClick event listener, btn send message dot add event listener, click. Let's add the function. So bt send msg on click. We'll define this function right now. So function send msg on click. So whenever we want to send a message, we're gonna type it over here and press this button, and after that this text is gonna appear as a list item to the unordered list underneath this chat text. So it's gonna be appended to this unordered list with the ID message list, and then we're gonna send the message across all data channels that we have stored in map peers. Alright, now let me just get this message list variable from above DC on message and put it somewhere towards the top. Let's put it right underneath this button send message variable, and we're gonna need the message input as well. Message input equals document.query selector, and the ID is MSG. Let's check it out. Right there it is, the ID is MSG, and there we go. Let's get the message from the message list, from the message input. Var message equals message input dot value. Let's create a list item. Var li equals document dot create element li, and let's append text to it. Li dot append child document dot create text node, and the text node should hold this string, me colon space, then the message. The thing is that when I'm sending the message, I'm gonna see that it was sent by me, and then I'm gonna see the message. So let's append it. Message list dot append, and then list item. Now let's get all the data channels that we've stored in map peers. So var data channels equals get data channels. We'll define this function right now. Let's get to the bottom, and function get data channels. At first, let's create an empty list. Let's call it data channels, and then we're gonna traverse map peers and get all the keys in turn. For peer username in map peers, so it's gonna traverse map peers and go through all the usernames. But in the end, we're gonna return data channels. Now for each data channel, var data channel equals map peers peer username 1, because the second entry will be the data channel. Push this data channel into this data channels list. So eventually we're gonna have all the data channels in this list, and then we're gonna return it. So let's get back to the message on send function, send message on click function. Alright, now that we have all the data channels in this list, we can traverse this list and send the message across all data channels. But before that, let's make a change to our message. Var message equals username plus colon space message. So whenever other peers receive a message, they're gonna see the username of the peer that sent the message, and then they're gonna see the message. So let's traverse the list for data channel in data channels. Since this is a list, I think we're gonna get the index. So for index in data channels index dot send message. Alright, now all we have left to do is set message input, set the value of message input to an empty string, because whenever we send a message, we want to clear the message input. I made a small mistake here. It should be data channels, and there we go. Now let's head back to the web page and check out everything we've done so far. Alright, so let's duplicate this tab, allow, and again allow. So let's call it A, let's call this one B. Alright, let's just mute ourselves, and let's call this one C. Let's mute this one as well. So there are 3 videos on each side. If we turn off the video on one side, it's it's closed on all other sides, and if we turn it back on, it can be seen again. And alright, now let's send a message. Let's say hello. So there it is, me, hello, and the other users are seeing the username C and then the message. So let's send a message from here, from A, right? Me, hi, then A, hi, A, hi, and then if we disconnect A peer, let's disconnect B. All right, we can see that B has stopped momentarily, and after a few moments, it disappeared. It's not there anymore. So let's disconnect A again. So A has disconnected, and it's going to take some time. And after a few moments, it's not there as well. Now I'm going to show you how to test it on multiple devices. And since we're not hosting it anywhere in this tutorial, we have to download something to expose our local host. So go to Google and type Ngrok download. Go to this link, download Ngrok, and depending on your operating system, you have to pick different links. Mine is Windows, so I picked this one. And when you download it, you're gonna have a compressed file. So unzip that file and put it in some directory. In my case, I put it in my F drive, and there I have this file called ngrok.exe. So once you have that file, you need to open it and then type ngrok.exe http 8000, and it's going to expose your local host and give you a public IP address. So okay, it's going to give you two public IP addresses. One is HTTP and one is HTTPS. You need to take the HTTPS ones because we're going to access our webcam, and for that we're going to need HTTPS. Otherwise it's not going to allow you. So take this HTTPS IP address and send it to the device that you want to test it on. So in my case, I'm going to send it to my mobile phone, and then I'm going to access my local host using this public IP address through my mobile phone. Now in order to access our local host through this IP, we need to go to our settings.py and make one change. Under allowed hosts, we have to add star. This will allow all hosts. But it's not a good idea for production. We're only doing it in development, and in production, you have to specify your hosts on your own. And keep in mind that whenever we refresh the Ngrok tunnel, we're going to have a new IP address. So let's restart it. Let's close it. Control C. And then let's restart it. Alright, now there we have it. So we got two IP addresses which are different from the ones we got before. One other thing, if you're testing it on your phone using the default built-in phone browser, then it's probably not going to work. And in that case, you should explicitly open a browser like Chrome and use that to test it. Now I'm going to try it out on my phone using this URL. So I've entered this URL on my phone, and now let's refresh this. And let's call it A, and for my phone I'm going to call it B. Alright, there it is. So let me just mute it from both sides. Alright, I've disconnected my phone. Let me reconnect it. And let me mute my phone. So there it is. There's the video from my phone, and here's my video. And also in my phone, alright, we can see that there are two videos here as well. So let me just disconnect this for now. Alright, that will be it for this tutorial, and I might make another tutorial for adding functionalities for multiple rooms and screen sharing, but that might take a while. And until then, I hope you found this tutorial helpful, and if you have any queries, let me know in the comments.